All right, so now we'll discuss endpoint traffic policy enforcement. So we discussed about the network enforcement for GlobalProtect. The way that works is different than endpoint traffic policy enforcement. So the enforcer for network is basically a feature which blocks or controls outbound access. So when the GP is not connected, you're basically blocking the user's ability to access internet and only allow certain URLs, which is outbound from the user machine to outbound. But what about the inbound traffic? For example, if you are in a public Wi-Fi network where you're connected to the Wi-Fi and there are a bunch of other users connected to the same Wi-Fi, and just by the nature of in the same network, another user or an attacker can run network scanners. They can find out open ports on your system, and they can still try to attack or try to connect to one of the open ports on your system, which might be uh, uh, which might allow an attacker to get access to your system and then do a lateral movement to your organization. This can happen in a corporate environment as well. So the whole idea is basically an option where you can control the incoming traffic as well uh, when the Global Protect is installed on that system. Um, the essential requirement is that unless the GP is connected um, and specific to the interface of Global Protect, you are not allowing any inbound communication or any inbound traffic coming from outside to that machine, which means the user can still access internal server, let's say printer, or it'll all depend on the configuration. Let's say you have a split tunnel for YouTube, so the user is still able to access YouTube. Uh, you may or may not allow local access, or you may or may not allow, um, let's say, a third-party VPN or any other specific network access. So that can still be controlled, but what you are blocking is, let's say, there are RDP ports open on your system, and you lock the screen, but you are on a unsecure Wi-Fi or a public Wi-Fi. Then the attacker is not able to communicate on that RDP port and get into your system. So that's essentially the idea of endpoint traffic policy enforcement. Now, what exactly we are doing here is we are blocking any inbound connection outside of the VPN tunnel. So the idea here is that again the GP the GP should be connecting. I mean the Global Protect should be connected. Once the Global Protect is connected, it does allow it will obviously allow the traffic from the GP, from the physical adapter to the Prisma Access Gateway to make sure that the tunnel is established. But uh, it will it will apply a kind of anti-tampering method, which will which will block other applications or users to bypass the routing table or tamper the routing table, where you can potentially allow incoming traffic from outside. When I say outside, from any other uh, machine or any other network or any other machine in the same network to that system. Now, there are certain options in regards to the endpoint traffic policy enforcement. You can focus only on the TCP UDP traffic, so that only the TCP UDP traffic which is going through the tunnel is allowed. And because it is going through the tunnel, it is subject to Prisma Access inspection, or if you're using on-prem firewall, your on-prem firewall's security inspection. So you can control rules and allow or not allow certain traffic, but you're not allowing anything outside of the tunnel. So a local RDP access or a local say SSH port access will not work, but it has to come through the tunnel so that it can communicate over a secure channel and you can do the full inspection there. Now, there are other parameters here. So there is something called DLSA, the direct local subnet access, where if a user is in a network, the admin can define if they can access their local network or no. So when I say local network, for example, you are in your office, um, and if you allow the local network access, you can internally uh, access the same network without going through the tunnel. But if you don't allow that, then that traffic also has to go through the Prisma access. So it depends on the organizational requirement, and there can be different use cases. But in terms of anti-tampering or the tamper prevention, what the GlobalProtect is doing is, let's say, another user with admin rights, they try to upload the GlobalProtect filter driver with an enforcement module. The GP will disconnect the tunnel. Because it has disconnected the tunnel, there is no access to the corporate resources because you need GlobalProtect to be connected to access your private apps. Thus, you're breaking that connection to make sure that your corporate network is secure. And if that kind of change does happen, the GlobalProtect will also send a message to PAN GPA, which will basically log this event. And the actual log will be in PAN GPS though, and as well as the troubleshooting log, because the GP is disconnecting. There'll be a troubleshooting .trb log, which will essentially show at the time of issue what exactly happened in a small log, that there was an attempt to change the filter driver, and then the GP tunnel got disconnected. Now we'll see a short video about traffic enforcement and how does it work. There are three scenarios.
This is Rachel. Let's deep
So
dive
we'll
into the capability
bypass.
of Let's take a quick look at the use cases of the feature. The first use case is full blocking or complete protection. This is achieved by enabling the endpoint traffic policy enforcement feature. Here, DLSA also needs to be enabled. This is the feature for no local LAN access. Everything here goes over the tunnel. The incoming traffic is restricted and local LAN traffic is also blocked. Here's the configuration for the same.
So we'll skip
We
the
go to the
configuration
necessary
part.
portal settings, go to the agent settings, and commit the changes. Here are two Windows machines on the same network. The IP address is 10.2.148.21 and 10.2.148.23 respectively. Here we see when GlobalProtect 6.0 is disconnected, we are able to successfully RDP within the local LAN machines. Let's enable GlobalProtect 6.0 now. Now, the RDP traffic is restricted as expected. Similarly, if we try to RDP from a different network, apart from LAN, the traffic is restricted as well. Here we see that we are trying to RDP into 10.2.148.21 from a 10.5.36.52. This traffic is restricted as expected. This completes the demo of complete blocking. The second use case for the endpoint traffic policy enforcement feature is to exclude network clogging domain, but also not allow local LAN network traffic. This is achieved by enabling the Endpoint Traffic Policy Enforcement feature. Here we select the All TCP UDP traffic option. Also, the No Direct Access to Local LAN is allowed. In our case, it is checked. Here, everything goes over the tunnel to exclude bandwidth clogging domains such as YouTube, which we have used in our demo. The configuration for the following is network,
We'll again skip
portals, go
configuration
to the
part.
necessary. Here is a quick demo of the same. The IPv4 address allocated to this Windows machine is 10.2.148.21. Now with the curl command, we can initiate TCP traffic to cnn.com or youtube.com using the physical interface, which is 10.2.148.21, and it is successful before GlobalProtect is connected. Also, here we see we are able to ping using the physical interface IP. Right after GlobalProtect is connected, when we try to ping google.com via the physical interface, it works because only TCP UDP traffic was restricted as part of the enforcement feature. ICMP will still work. But as we see, all other TCP UDP traffic will be restricted, for example, CNN.com. But since YouTube.com is excluded, we see that we are able to successfully access it. Here we are trying to access youtube.com via the physical interface and it works. In this third use case, you can use the endpoint traffic policy enforcement feature but still allow local LAN access for resources like printer. The configuration that is done for this is enable the endpoint traffic policy enforcement feature to all traffic. The no direct access to local network is disabled, meaning local LAN access is allowed. We can access local resources like printer in this case. The outcome is everything goes over the tunnel. All TCP UDP ICMP traffic goes over the tunnel, but access to printer or local LAN is allowed. Over the physical interface. The configuration for the following is as below. Go to Portals, select the necessary portal setting, the agent, exclude youtube.com for our demo. Here is a quick demo of the use case. We have two Windows machines in the same local LAN. The IP addresses are 10.2.148.21 and 10.2.148.23. For TCP traffic, and since we disable access for local LAN, it works. Here we go ahead and enable GlobalProtect. With the traffic endpoint enforcement feature enabled to all TCP and UDP traffic in conjunction with local LAN access being allowed, and we are still able to pass TCP traffic between the two machines successfully. Here we see different subnets and we are able to RDP from one subnet to the other when GlobalProtect is disabled. Now we go ahead and enable GlobalProtect. And now when we try to pass TCP traffic, that is RDP, from a different VLAN, the RDP fails. Try to access TCP traffic via the physical interface and the curl command fails. Since YouTube is excluded within the feature, we are successfully able to access youtube.com. This concludes the demo.
All right, I'll stop that.
Hi, this is
Okay, so I hope this demonstration was helpful. So you would be able to watch the entire video with the YouTube link. It is there on Live Community. The basic idea there was to show the three use cases of endpoint traffic policy enforcement, and how does it essentially work, and what are the criterias there in terms of how the traffic works, what is allowed, what is not allowed. Um, this flow would give us a better idea in terms of what's allowed. So here, basically, say a packet comes from outbound to the tunnel IP. If it is coming to the tunnel IP, it means the GP is connected, and you're sending something on the GP IP, which is presumably coming through the tunnel, which means it's inspected by the Prisma Access, so it's allowed. Um, then if the incoming packet is not for the tunnel IP, and it is coming to the physical interface, then the next step is to check if the protocol is excluded or not excluded. For example, if you only uh, enforced it for TCP UDP, then other protocols are allowed. Then you allow that packet. If, let's say, we are blocking everything, then we are not allowing the packet, but there are still a few. We'll talk about those protocols like DNS and DHCP. So there are few protocols which are still allowed for the basic networking to work with this enforcement. So they are still allowed. Now, the next part is split tunneling or exclusion. So, for example, as we saw in the demo, say, for example, you excluded youtube.com as a domain, or you have access routes where there are specific subnets which are split tunneled. So, when the user is in office, they don't need to go through the GlobalProtect network to access their internal resources. There are internal networks which are subject to split tunneling. Because they are split tunneled, that traffic is still allowed on the physical interface. Otherwise, your split tunneling functionality will not work. So that traffic is still allowed. Now, within split tunneling, we need to be aware of a few caveats, which will uh, take note again in the next slides. Essentially, the domain-based split tunneling would work based on the DNS resolution. Um, tunneling on day 3, but when we are talking about domain-based split tunneling, the GP client needs to see the DNS request for that domain. For example, youtube.com. There should be a DNS request when the GP is already connected, so that it can see the DNS request, it knows what is the IP address, and then it can dynamically allow that IP because that's not part of the IP-based exclusion. So this would help us understand how does the enforcement logic works with endpoint traffic policy enforcement. And if none of those parameters are correct, none of those parameters match, then we're essentially blocking that packet. Now, in terms of this module, um, what are the requirements and when do we use this module? As we discussed, endpoint traffic policy enforcement would only work when the tunnel is up. So the criteria is you're essentially using always on mode. So the GP, all your corporate the machine, they need the off internal gateway. Outside of office, it can be it will be external tunnel to your either Prisma Access gateway or your external gateway, but the GP should be connected. Because the GP is connected, all your traffic is secured through your firewalls, through Prisma Access, and anything outside it will anything outside of that is not subject to split tunnel. The any traffic base would not work. Now, you theoretically use the feature in on-demand mode as well, but the functionality is not of much use, because if you are allowing the user to just disable the GP when the GP is disabled, the incoming connections would now work, and there's not much use of this feature, at least at that point of time, because the tunnel is not there, and as long as the tunnel is not there, uh, the GP does not turn this feature on or block any incoming connections in the background. For the enforcement of network traffic, it does. So outbound connection, if you configured that, um, there the GlobalProtect will, if the GlobalProtect service is running, it will still apply enforcement. But both of these features are usually used when you have the always on mode enabled. Um, for pre-log on and on demand, or pre-log on and always on, um, the enforcement part would work only when the tunnel is renamed. So for example, if a user has not turned on the machine and the GPS connected using machine certificate, at that point of time, not all the features or all the services on the system are running and the user is not logged on. In the endpoint traffic policy enforcement doesn't kick in. It does kick in after the timeout occurs. The pre-logon tunnel is user logon tunnel, and then as long as the tunnel is connected, that feature is on. And when there is an internal gateway, that's a use case when you are in an office, when you're in corporate office where you have internal host detection. The, if there is no tunnel, again this feature isn't really. Then the responsibility of blocking incoming connection is on your internal firewall. So corporate network, they have their edge firewall, which is controlling the incoming connection, and everything inside the network is already trusted. That's why there's no tunnel. And because there's no tunnel, the feature is basically disabled. Now, there is a way where you can change that. You can, if you have a Palo Alto firewall in your corporate network as your edge firewall, you can configure an internal gateway there to have a tunnel. So what that will do is, even when there is an internal host detection enabled and the GP detects that it is internal, you can still configure the GP to establish a tunnel to that gateway. But the requirement for the endpoint traffic policy enforcement feature is that there should be a tunnel. Now, we'll discuss about some more caveats here. So the TCP handshake packets are bypassed. The reason is the GP would still need to look at the traffic when the enforcement module would look at the SYN, SNAC, ACK packets, and those packets would be bypassed. But then, other than that, when the actual data comes in or any actual traffic comes in, that will be blocked, assuming it's not subject to split tunnel exclusion, or it's not part of a protocol which is already allowed. As we discussed for the destination domain, so this destination domain is talking about split tunnel. As we know, there is a split tunnel configuration option for domains, say, for example, YouTube. So if the system already has DNS cache for YouTube, it knows the IP address. That traffic will still be blocked. That traffic can still be blocked because the GP doesn't know the IP address with the DNS request, because the DNS request did not occur when the GP was connected. So um, what that will do is, once the cache expires and the user again tries to access that URL, and then that the FTDN to IP resolution comes in picture, the GP knows that IP, and then it dynamically allows that from split tunnel as well as endpoint traffic policy enforcement. For Mac OS, there are a few specific caveats. So these are for Windows. This one is for Mac, that the exclusion for application will not work for any new any new incoming connection or existing connection. When we say application, we are talking about again about split tunnel for application. You have an option where you can define specific applications with the plist path for exclusion. So that does not apply on Mac OS. And on top of that, for port 53 and 5353 is by default allowed. So even when you select all traffic, we still allow 3 and 5350 DNS and other Mac specific functionality to continue to work even when that feature is turned on. And for Windows, it's the traffic, the UDP 67, the DNS 53 is allowed. Another caveat is if you're using virtual machines on your on the user laptops. So for example, there are bridge mode networking where there is a machine which has another VM running inside of it, which will obviously have a completely separate network stack, but then it is using your access the network. So the feature doesn't work on the bridge mode networking for the layer 2 control. The way to
Hey,
control.
Yogesh, your audio kind of cut out there. Could you say that last part again?
Sure. Yeah. Just a minute.
You were talking about the virtual machines, and you kind of cut out there.
Sure. Yeah. Thank you. So we are talking about the virtual machine on users' physical laptops. So there are use cases where there is a, let's say, a Windows laptop which is running uh, VMware virtual machine, which can run other Windows or Mac OS or other OSs, and then can be done for Mac. In those cases where the virtual machine is running in bridge mode networking, where the guest machine is using the physical machines or host machines physical adapter to access the network or accept incoming connections, there this feature cannot be used with the bridge mode networking. The way to control this is you can use the bridge mode for virtual appliance using a layer 3 NAT. So you define a layer NATed, and then you're applying the endpoint control on the actual physical adapter by you're basically blocking any incoming connection irrespective of the adapter that it is coming to.